In this equation right here, we're given a quadratic equation, and we will be using the quadratic formula to obtain our x-intercept. So the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. In the previous video, we were able to show how this quadratic formula actually works because we were able to derive the quadratic formula from completing the square root of the quadratic equation. Now right here, the reason we are going to be using the quadratic formula, because notice that right here, if I want to go by factoring, it's hard to factor this function. The reason is because if I have my multiples of a times c, which is 1, there is the only multiples that multiply to 1 is 1 and 1. And 1 and 1 cannot obtain for us, if we add them together, that we can obtain the b value, which is 5. However, we can't assume that there is no x-intercept just because factoring doesn't work here. So that's why we always, whenever we have a function that is hard to factor, we always use the quadratic equation. So the first thing right here, I need to identify what my a value is, which is 1. My b value is 5, and my c value is 1. Now all I have to do right here is take these terms and plug them into the quadratic formula. So here I would have x is equal, my b value is 5, so it's negative 5. Notice that the quadratic formula always has the negative in the front of the b on the outside, plus or minus the square root of b squared, which is 5 squared. I always emphasize to use parentheses even if it's a positive number, minus 4 times a, which is 1, and times c, which is 1, and then all over 2 times 1. And now here I'm just going to use my order of operations to simplify my answer. So the negative 5 plus or minus, I need to work underneath the square root. So now 5 squared is 25, minus 4 times 1 is 4, all over 2 times 1, which is 2. So now here x is equal to negative 5 plus or minus 25 minus 4 is 21, all over 2. This can't be reduced any further, and that would be my final answer. And I can always separate my answers to write the positive value of the square root and the negative value of the square root separately. So now here it'd be x equals negative 5 plus square root of 21 over 2. And x is equal to negative 5 minus square root of 21 over 2. You can use a calculator to evaluate your value. Here I'm given the x squared minus 3x minus 5, and I will be using the quadratic formula to solve for my x-intercept. So again, my quadratic formula is x equals negative b plus or minus square root of b squared minus 4ac all over 2a. So the first thing I need to identify my a value, which is 1, my b value, which is negative 3, my c value, which is negative 5. So after I have my a, b, and c, I'm just going to plug them into my quadratic formula. So now here it's negative. My b value is negative 3. Again, using parentheses is really important solving these formulas. And then square root of b, which is negative 3 squared, minus 4 times a, which is 1, and c is negative 5, all over 2 times a, which is 2 times 1. Using the order of operations now, I'm going to reduce, or I'm going to simplify my solution. So negative times a negative 3 gives you a positive 3, plus or minus 3 squared is negative 3 squared is 9, minus, now notice it's a minus and a minus, so that gives me a positive. 4 times 1 times 5 is 20. all over 2. Now I can add the 9 and the 20, gives me 3 plus or minus square root of 29 all over 2. I can't reduce it anymore, so that would be my final answer. Again, I can write my answer as two solutions, 3 plus square root of 29 over 2, and x equals 3 minus square root of 29 over 2.